Welcome to the fifth and final video of Chapter 3. This will be a fairly short one. We're just going to be covering two slides. And the first one is about interpreting and communicating the results of a study. And these are all important points, and I've alluded to some of these before. So first of all, be careful not to generalize results to populations not found in the representative sample. So remember, I talked about samples earlier, and you try to have a sample that represents the population that you're interested in. And I mentioned at the time that if I was to do an experiment with all males, I wouldn't want to generalize my results to also apply to females. If I didn't have any in my study, I can't really assume that the results would be the same for females as males. Similarly, if I had all, let's say all non-Hispanic white Caucasian subjects, I wouldn't really necessarily want to generalize my results to other ethnicities. If I had all 20-year-olds, I can't really generalize my results to 50-year-olds, So this is why it's very important when you select your samples that you represent the group that you want to generalize your results to. If I think my results are going to apply to children from 5 to 10, I want to make sure I have a good sampling of 5 to 10-year-olds, and including males and females and different ethnicities and things like that. Okay, so that's the first point. Second point, understand that most results are averages and won't apply to every individual. And I've kind of talked about this before too, that this is what we look at in developmental psychology. A lot of the results we'll be looking at, they are averages. They're like what we expect the typical child to develop according, we'll talk about like the typical developmental patterns. But understand there are always in every result there are people that do not fit the pattern. Okay. In those we refer to those as individual differences, and it's often important to study individual differences and why some people don't fit the normal pattern. Third point here, statistical significance implies that the results were not found by chance. It does not mean the results are of great practical significance. And this is one example that of where many people make this kind of mistake, because it sounds important. You hear this result was statistically significant, and you think, oh, significant. Statistical significance just means that the results are likely real and not just a chance result, not just a fluke result. It has nothing to do with whether they are important or not. So you may get a study can get results that are statistically significant, and yet they may be the most boring results in the world. For instance, I can assure you that if I was to measure all your heights and your shoe sizes and then do a correlation, I would find a statistically significant positive correlation, which would tell me that people that are taller tend to wear bigger shoes, and people that are shorter tend to wear smaller shoes. Not very important. It would be statistically significant, but it's not really lending a lot of interesting information to our science. So one thing we want to look at when you hear that result is statistically significant, it's often important to look at what's called the effect size. And the effect size tells us how large the difference is that was found between the groups. So it doesn't just tell us that there's a I'm getting tongue-tied, statistically significant result. It will tell us how much were the groups different. So I'll give you an example here. There was a group of 250,000 men in the Norwegian military that were studied, and they found that firstborns had statistically significant higher IQs than second-borns out of that sample of 250,000 men. First-borns had statistically significant higher IQs than second-borns. So you think, whoa, that's really interesting. I mean, the firstborns, for some reason are smarter than secondborns, But then when you look at the effect size, you find that it was only 2.82 points, and that's very small in terms of IQ. So it's less than 3 IQ points difference. So the result is real. We believe the result because it's statistically significant, and that's what that means, that we expect that we would get the same result again if we were to replicate the study. We have confidence in the result, but the result's not that important. Under 3 IQ points is nothing, and if they were 10 points apart or something, well, then there would be, you'd want to do additional experiments to find out why are they significantly smarter. In this case, under 3 IQ points means that they're almost identical in intelligence. You would have trouble telling apart the intelligence of people that are less than 3 IQ points different. Okay, that once again is called effect size. In this last slide, if I can get there, here we go. We're going to look at the ethics in research with children and adolescents. And I'll go through this fairly quickly. It's pretty straightforward. First of all, you want to minimize risks, particularly when working with children or adolescents. I mean, that's really true in any experiment of any age group. But you are expected to take even extra caution when working with children, particularly, very young children, because they can't necessarily speak up for themselves or understand what's happening. So you need to be, or to tell you if they're having difficulties in the study, or so you have to be really careful that you're not putting them in any kind of harm's way. They're not necessarily good advocates for themselves, especially if you're working with infants or something. Informed consent of parent and child. The consent of child is important if they're at least 7 years of age. Then they have to consent as well. You cannot just rely on the parents. So for 6 and under, we allow, the parents to make the decision for the child. But even though that guideline's in place, if you have a 5 or 6 year old and they're absolutely saying they don't want to be in the study, there's no way you would be unethical to run them in the study. So I'm just saying that legally, like you don't have to get their consent, but there's nothing wrong with asking, preschoolers or young children if they want to participate in the study, even though the parents may have already consented. Right to withdraw from research. This is true in any research that any age subjects, they always have a right to withdraw. You cannot make them finish. You cannot hold them against their will. It is just simply an experiment. They can quit at any time. And it's important to make sure the children or adolescents are aware of that. If you ever want to stop, you just say stop and we'll stop. And then finally, privacy and confidentiality of information. Once again, this is something it's true at any age, but all these things, even though they may be true at other ages, it's hammered in to take extra cautions with children or adolescents. So you should never identify, this last one just means you should never identify any of your subjects by any revealing information. So you don't use their names. You shouldn't even use their initials. You should just have codes for them, like subject 58 or subject, 92 or whatever. And so you might assign a number to them or some random set of letters. This was subject A, B, Q, for instance. That doesn't reveal anything about the person. Okay. And that will conclude Chapter 3, How We Study Development.